Prime and composite numbers play a crucial role in a very important theorem in math. You might even say it's fundamental. Keep watching. Welcome to Math Bytes. I'm Allison, and today we're talking about prime and composite numbers. A prime number is a number with exactly two factors, 1 and the number itself. So for example, 2 can be factored as 1 times 2. There aren't any other factors of 2. 3 can be factored as 1 times 3. There aren't any other factors of 3. 11 can be factored as 1 times 11. Again, there's no other factors of 11. These are all prime numbers because their only factors are 1 and the number itself. Now what if you have something like this? 6. 6 can certainly be factored as 1 times 6, but it can also be factored as 2 times 3. What about 15? 15 can be factored as 1 times 15, but also 3 times 5. So these numbers have more than just those two factors, and that makes them composite numbers. Composite numbers can be expressed as a product of prime numbers, and to do that, we can use what's called a factor tree. So let's factor 30. Now, when you're going to factor a composite number, just pick any two of its factors. Doesn't matter which two they are, but don't pick one and the number itself, because that won't get you anywhere. So we're going to factor 30 here with a factor tree, and I'm going to pick the factors 5 and 6. So I'm going to write it like this. 30 factors as 5 and 6. Now, are there any factors of 5 besides 1 and 5 itself? No. So that branch of the tree is done. That's a prime number. So I'm done there. What about 6? Well, 6 will factor as 1 and 6, but I don't care about that right now. It'll also factor as 2 and 3. So I'm going to write those down. So 6 factors as 2 and 3. Now, 2 is prime and 3 is prime. So now I'm down to prime numbers, so I'm done. So 30 factors into 5 times 2 times 3. And it's standard that we put the numbers in order from least to greatest. So that's equal to 2 times 3 times 5. That is the prime factorization of 30. Let's factor 30 again. But this time, instead of starting with 5 and 6, I'm going to start with 3 and 10. So here we go. 30 factors as 3 and 10. 3 is prime, so I'm finished with that branch of my tree. What about 10? 10 factors to be 2 and 5. Now again, 2 is prime and 5 is prime, so I'm done. So 30 again equals 3 times 2 times 5, and putting those in order from least to greatest, 2 times 3 times 5. That's exactly what we got last time. And that leads us to this. The Fundamental Theorem of Arithmetic says each composite number can be expressed as the product of primes in exactly one way. So it doesn't matter which factors you start with on your factor tree. Once you factor down to primes, the product of primes will be the same. And that's what that theorem tells us. Let's do another example. Let's factor 90. All right, so I'm going to start with 2 and 45. All right, 2 is a prime number, so again, I'm done with that branch. What about 45? Well, that factors as 5 and 9. Now, 5 is prime, so I'm done there, but what about 9? Well, 9 factors to be 3 and 3. Now I have all prime numbers at the end of my branches, so I'm finished. So the prime factorization of 90 is 2 times 5 times 3 times 3, or writing it in standard form, 2 times 3 squared times 5. Now, I want you to factor 90 again, but I want you to start with 9 and 10. And I want you to make sure you get the exact same prime factorization as I did. As numbers get bigger, it can be a little less clear whether they are prime or composite. So if you're trying to figure out whether a large number is prime, go through some common factors, some common prime factors like 2, 3, 5, 7, 11, and see if any of those are factors of your larger number. If they aren't, you'll probably get to the point where you can determine that it is in fact prime. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if there's something you'd like to ask us, just send us an email. We're at contactmathbytes@gmail.com, and I'll see you next time.